I'm
Yeah.
heavily involved in like what we do specifically as like for the shower max detector inside of this larger. You have no context. Sorry, I just realized that.
Just gonna
I'm just
save
like
my
for me,
questions
it's
till
like
the end.
it's like everyday language. So
Yeah.
it's like to me, it's like we're talking about the weather. But so MOLLER experiment is gonna take electrons and then shoot them at hydrogen, right, which has electrons weakly bonded to the, you know, I should probably take that part out. It's not like
As
weak.
everyone
It's
knows.
just a
Yeah.
hydrogen atom has a proton and electron, right?
Yeah.
And so a lot of the time, what happens is this electron will interact with the other electron, right? So it smacks into it. Now, a couple of things can happen. A lot of different things can happen, but one main one is they interact electromagnetically, so they push each other away, right?
Mhm.
Because they're both negative charges, and they push each other away. Sometimes they interact weakly through the weak force. Weak force is sort of this. It's kind of mysterious, even, but you can think of it as maybe even another aspect of the electromagnetic force. Really, so it's the reason it's so strange. It's because it's really clear what the other forces are doing, and it's not exactly always clear what the weak force does. So like electromagnetics is like really straightforward. Most people just understand that intuitively from like because we use electronics, right? And we use electricity, and so we have some, and we have magnets, and we know what those are, right?
Yeah.
Um, but the and the nuclear force, the nuclear strong force, holds everything together, right? And so that's what is keeping the proton, the quarks inside of a proton together, right? You can't pull them
Right.
apart. If you pull them apart, they make anyways. So that's the strong force.
Uh-huh.
Um, but the weak force isn't one of those. You know what I mean? It's not like clear what it's doing. Gravity is really straightforward. You know, everybody knows what gravity is. But the weak force is kind of like, oh, I don't know, really know what it is. It's only apparent in like, to me, it's like really obvious when you have particle interactions, and then you say that they had interacted weakly through this other force, right? Um, and mathematically, it all makes sense, and you know, and all that, and it's like really well established in physics, but it's not easy to like tell someone what it's doing, right?
Yeah, I'm not gonna lie. The idea that something isn't so well defined or is vaguely described by some things sometimes isn't it's not giving me a warm and fuzzy about it.
Yeah, it's well, it's like it's very well established in rigorously understood mathematically and in theoretical physics, right?
Mhm.
And so it's not a mystery there necessarily, and it's easily treatable like the rest of the forces. It's just like hard to explain to somebody like what it's doing, you know? Because like a magnet's really simple.
Yeah, okay. Okay, I got you.
Yeah, one idea. So, what a unified theory is. So, everyone wants to know like what the theory of everything is, which is not something you can actually do, but you could do it from a position maybe. But from a if you took a perspective, you could maybe make a unified theory. So, all the forces should be the same thing at some level, right?
Sure. Yeah.
And that's what a unified theory is, right? But we can already kind of unify electromagnetism and the weak force. And so a lot of the times it's referred to as electroweak, right? And so technically what I do would be like electroweak physics, right? I say
Damn.
nuclear. Yeah. I say nuclear because it's technically it's really hard to differentiate, you know, what at this level, right? They're all
Yeah.
kind of very similar things, right?
Yeah.
Um, but yeah, it's electroweak physics, and this group specifically that I'm a part of doing the MOLLER experiment, it's an electroweak group, and that's what they're looking at. Is there's a specific parameter that you get from the math of these interactions uh, that you can determine experimentally, and we can do that with a very high precision.
Mm.
Um, and so that's what this experiment is going to do. It's going to look at the scattering. So, like that electron going back to there, the electron hits the other electron. Sometimes it's electromagnetic, and very rarely it's weak, right? And they interfere with each other in such a way that we can basically look at. So, those keep going, those electrons go. They make their way through a detector, and we get a certain amount of light because they hit quartz, and in quartz the electron is traveling faster than the speed of light, and so that creates the in quartz, not the speed of light itself, like in a vacuum. So the speed of light is the speed of light in a vacuum. That's what people mean when they usually when they say it, right?
Yeah.
But inside of a material, inside of a medium that's not vacuum, the speed of light can be less than the speed of a particle.
Right.
Does that make sense?
Yeah. Sorry. I guess I got hung up on something because yeah, I was always tracking that like going through stuff tends to slow it down. I didn't consider the relationship between a particle going faster than the slowed down speed of light. That's
Yeah.
yeah,
Weird,
it's
right?
weird. Yeah,
It's very yeah,
it's weird.
it's kind of cool. So what happens is that particle, it's sort of like a sonic boom. Actually, it's very. That's actually an accurate way to describe it. So,
It's a light boom,
what?
right?
Yeah, it's a light
Yeah.
boom. You get a light boom, and it creates this wave behind it, right? And that's Shrankov light, and we call it Shrankov light because he was the one who nailed down what it was, right?
Uh,
So, this light, this Shrankov light, um, we know the characteristics of it, we know what's going to happen, and we make the quartz detectors such that that light will totally internally reflect on the sides of the quartz and then make its way up to a photomultiplier tube, which is just a fancy way of saying that when light hits this surface in the photomultiplier tube, it has a way of turning that into an electrical signal through the photoelectric effect,
okay.
So then we just get a current, right?
Mm,
So we get a light level. We do this a billion times. We do it a couple million times a second or whatever.
mm,
We get a certain light level that we see from all of our detectors, right? Uh, for the electromagnetic, and we get a certain light level. Um, it's more complicated than this. I'm simplifying it, and then, but let's say when it interacts weakly, we get a different signal. It's
okay.
a bit more than that, but that's the gist of it, right?
I'd assume it's a little more than that, but yeah.
Yeah. Well, what's actually happening is that there's an asymmetry. So when we shoot the electrons, and let's say there's their spin polarization is this way, or I guess it would be up. I actually don't know how the beam is set up because I haven't even thought to ask. But anyways, you swap, right, the helicity of the that's called helicity. So I don't want to get into all that. You know what I mean? But you flip it back and forth like this, right?
Yeah, yeah.
And what'll happen is there is an asymmetry. We can't actually look and say that was a weak interaction, right? What happens is when the electrons are going this way, let's say they're pointed this way, their spin is pointed this way,
Mm,
we get a certain light signal. And then when they do this, the weak force is it's not symmetric. And so we get a different signal when it's this way. Does that
mm.
make sense?
Yeah, yeah, yeah.
We can tease out through these light levels, we can tease out what was happening at the target. And then we'll get an answer for this. It's called the Weinberg mixing angle, mixing because you have the weak and the electromagnetic force, right? And we get a very specific answer for that, and it's highly precise. Does that
Mm.
make sense?
So at the end of all of this,
Yeah.
the goal the goal for the results of this experiment are to what? What do you apply those
Get
results?
that parameter. You want to know what this value is very precisely.
Mm,
So one thing about, let's look at like high energy physics. So this isn't high energy. This is still like relatively high energy. It's like five. I think it goes up to like 11 GeV, giga electron volts, which just think of that as an amount of energy. But like in the at CERN they're using way higher, like in the hundreds, maybe in the I think even the TeV, like tera electron volts. If I said
Jesus.
that,
Okay.
yeah, yeah.
Gotcha.
I think not always, but like they get extremely high, right?
Yeah.
I'm not sure if they've actually gotten that high, but it's very a lot higher, right?
Yeah.
So that's called high energy physics. The one thing about that is that you have to do a bunch of statistics and then you can get a pretty good answer, right? And
Mm,
so uh, the difference here is that we get a bunch of statistics, but so precise that the error in the experiment from all of our equipment and from our own measurement taking techniques is less than the statistical error that is inherent to the experiment itself. So we have an error bar that's smaller than the statistical error for taking measurements, period.
That
And
sounds
so,
good.
yeah, it's high precision. So we know with a really high degree of precision what our answer is, right? And so this
Yeah.
can complement high energy physics, where they're kind of like they get a lot more. It's a lot wider, right? The
Yeah.
statistics are not. It's just, yeah. So the error in their measurements is just higher, and so we kind of like take more elegant. Elegant's not the right word, but that's kind of the way I think of it. It's like it's just like this sleek little sexy.
No, yeah, no. Talk shit on them. Yeah.
No, I mean they're obviously like the smartest people in the world. But,
Yeah. No, that's really cool though. That's
yeah.
pretty cool. Huh. Okay. It's
So you
funny.
get this answer, and it like to answer what you had said. You had asked if it was like the point is to get what exactly? It's to get this parameter that can assist with other measurements that have been taken, potential candidates for dark matter. You can draw conclusions from it. You know what I mean? And you can use it to help assist in other decision. Like what we know this really precisely. So what's this? That kind of thing.
Yeah, yeah, yeah. Gotcha. I'm I was thinking of an analogy. It's probably not going to make any sense, but it would be like if you had a wave coming across an ocean and there's a seabed underneath it, and a certain level of wave is generated while the water crosses over it. You're answering one of the things that could be taking up the volume on the bottom of the ocean that could kind of fucking slot in that spot. Is that what you're saying? Or is it like if you had two rocks, right?
Yeah.
Like one's a big rock, one's a small rock. I don't know how big they are, but if I know how big the small rock is, then I know how big the big rock is. Is
Okay.
that anything?
Or what people want this measurement for.
Yeah.
You
All
know what
right.
I
Well,
mean?
that makes me feel. It makes me feel better, at least. So.
Yeah. A part of a long chain of experiments, which a long lineage, which is I have respect for. Like, it starts with like the Wu experiments in the 40s and 50s, I think, or 50s, where they looked at these parity violating, um, you know, measurements, and so it's a really interesting historical thing. But personally, I prefer to craft my own questions and then investigate those how I want.
Yeah.
You know what I mean?
Yeah.
And like think of really clever ways of doing things that I like. I love having the ability to determine something from a very small resource set. You know what I mean? Like so it's like when your back is pushed against the wall and you have these constraints and then you figure it out and then suddenly you're able to do what you couldn't have done when you had twice as many resources. Does that make sense?
Yes. No, I
So
get
I
it.
would like prefer to can we determine some of these things with like a really in really unique or clever ways, and I'm not even certain if I would want to keep doing these type of interaction type experiments. There's a lot of things that I'm more interested in, you know,
Mm.
um, that I would prefer to do. And so I was kind of like, but I haven't, and the physics is already done. And so it's not like there's no room for theoretical physics on this experiment. It's really just like experimental. Like I have to like figure out with what is actually happening at the detector. Like what are we seeing? What's the
Hmm.
background? What's the signal? What are the characteristic signatures of what? I have to just figure all of it out, right? And so I have to be able to kind of make a map from like what we're seeing at the shower max detector to what happened in the target, right? And there's
Right.
a couple of different versions of targets. Um, there's a calibration thing, and then with that calibration thing, we get certain patterns, and I have to know what those are to inform when we take that calibration thing away. When we get the real target, it's running much higher energy, much faster, and we can't. There's no characterization. Then we kind of have to just know what happened during the calibration phase to be able to determine what happened during the target phase, right?
Hmm.
And so, um, shit, that's actually pretty soon. You can always do it post. You can always do it after. As long as we have
Yeah.
all the data. but it's a lot better if you have a better idea of what's happening while it's because then it's like, hey, wait, can we do this? No, it happened 6 months ago. It's too
Yeah.
late. so
Yeah.
so yeah, so it's like it's called kinematics. So I'm characterizing the kinematics of the beam for the shower max detector.
Yeah. Okay. Also, I gotta ask: are you saying shower max?
Yeah, like the word shower,
Yeah.
like a shower, and then max. And so the reason, yeah, why is it called that? That's a good question.
I was a little curious, but
Um, so shower max is an electromagnetic calorimeter, and so it gives you an energy dependent signal, whereas like the main detectors are just literally pieces of quartz, right?
mhm,
Synthetic fused silica, they're high purity synthetic fused silica. It's not like just go dig up some quartz out of the yard or something. It's
right.
you
Yeah.
know really finely polished and all that. But Shower Max is made of quartz detectors. So we have quartz tiles, but then we have tungsten, quartz, tungsten, and we have 4 layers of each.
Hmm.
So we have stacks, right? And what happens is that particle comes in and it moves through the quartz nice and easy, right? It makes Trank off radiation, but not a lot happens. It smacks into the tungsten. Tungsten is extremely dense, and it makes a lot of other particles, right? And so what happens is you get a whole bunch of particles and that spreads out and then it goes through the quartz, then it goes hits the next tungsten tile and those all make more particles and then you get a shower, right? And so what
Gotcha.
happens is before it exits, you've made a shower of particles um, that is directly dependent on the amount of energy of the incoming particle.
Makes
Right?
sense.
Yep. And so what we can do then is say, oh, this signal right here was whatever. And then we can say that is too low. That's a background signal. And so we can actually help with, so we'll get a measurement of the Weinberg mixing angle, but we can actually do energy corrections. Whereas the main quartz detectors can't. They don't know it's moving through quartz. It's not going to deposit more or less energy necessarily, depending on how fast it's going. So it can't tell the difference between 2 GeV and 8 GeV
Oh,
electron.
okay.
It's just not. Whereas shower max will have a pretty clear difference.
Gotcha. Gotcha. How sensitive is it to background?
Um, so we can pick up. You know what MIPS are?
No.
Minimally ionizing particles.
Cool. No.
Yeah. You know
Yeah.
what muons are?
Yeah. Uh-huh.
Okay, so you have a whole bunch of muons showering through you right now from the
Yeah.
atmosphere, from the cosmos, right?
Love it.
The
Yeah.
universe. Yeah. So we can pick those up, right?
Mhm.
So you can see things like that. And those are like I think on the order of like hundreds of MeV, a lot less energy.
Okay. Gotcha. Okay.
Yeah.
Yeah. So
Anything
sensitive.
that's going to ion so minimally ionizing, that's the key word there. So anything that's going to ionize, it can pick up,
Gotcha.
right? And you're not going to get shrink off radiation or you're not going to get a lot of it from, and you got to remember like this, so it's like a complicated experiment that takes decades to like figure, well, I mean it takes a long time to figure all this stuff out because there's a lot of things happening, and you have the electronics and they have their own problems and their own, they're opening, your electronics itself is opening a window, receiving information, closing a window, and there's timings and there's delays signal and there's all this stuff, and it's a huge thing that takes, it's
Yeah.
like
Yeah.
so it's not like simple. I'm oversimplifying everything. Like, yeah, it's pretty
Yeah.
complicated. Like there's physicists that literally spend their entire careers just working on the equipment that reads the electronic signal from the
That makes
PMTs. You know what I
sense.
mean? And that's
Yeah.
what they do. That's like they're the data acquisition is like a
Yeah.
whole thing by itself. That you can spend your entire career on. So yeah,
That's a choice. And you got to really love what you do. I feel like if you're going to spend your entire career working on
yeah. I'm
improving one system, but
I'm not I'm not really like, yeah. And then there's like physicists that just deal with, I forgot what it, there's all kinds of little things, and that's like, and then you become that guy, and then the problem is every time you get picked up for another major experiment, you're just that guy, and they're like,
yeah,
and you're gonna do it now because
I
you're
feel
the
like that
expert.
happens. I feel like that happens in a lot of tech related and science related fields, right? It's like
Yeah,
you kind of get your foot in the door, you start working, you learn something really, really well, so everyone starts coming to you for that one thing.
yeah.
Yeah, and then you're
And then
just
that's just
the
you.
guy. Yeah,
Yeah, you're the
I guess that
guy.
happens in every industry, right?
Yeah,
But
Well, it's like your name is like on half of the stuff, and it's like let's
Yeah.
just call this guy. You know what I mean?
Yeah.
It's like because you wrote this program 20 years ago, and it's still there, and
Yeah.
yeah,
Fucking WinRAR. Never paid for it. Um, but
yeah. I
yeah.
have more interest in being like more of a Batman kind of, where I just want to like figure all of it out. You know what I mean?
I think that's isn't that more like a it's more like a Tony Stark type, isn't it?
Yeah, I guess.
Yeah.
Yeah,
I feel
but
like
like if you
Batman
can
just
do anything, that's
yeah,
sort of Batman's superpower. Batman
I
can just
guess.
kind of do anything. You know?
That's true. Yeah, especially the new ones where he's just like creating a car. You're like, you're a you're a billionaire.
Yeah, yeah,
When did you learn how to put together a fucking car? But
yeah.
yeah. Not that he couldn't do it, just yeah.
Like I'm not very good at anything in particular, but I can kind of do any like most in generally when you run a research group that you really just kind of become a person that has to do all of it anyways. And so
Yeah.
um and physicists, experimental physicists in general kind of just figure all of it out and they just kind of do all of it themselves, more or
Yeah.
less. There's never like a, oh, I don't understand electronics, so we need to like send this to, it's not like, it's just like you're gonna become an electrical engineer today.
I guess I mean it would be a hard pill to swallow, right? If if you dedicated your life to knowing everything there is to possibly know about physics, right? Or at least a branch of physics, and then you get stumped by something like a microcontroller, right? You're like,
Hmm.
it's made of stuff I know about. Surely I could
Yep.
figure out how electrons and fucking and silicon fucking work. But
Yeah. Well, when
yeah.
I did my master's thesis, I looked at radiation damage and the type of quartz that we were going to use for this experiment.
Mm,
And I had to learn how the CCD controller, or the CC, what is it? So when you take a spectrometer, right?
mm,
It has basically the same thing that's in a camera, more or less, that um, you know sees the light and how you get an actual image, right? So the like actual electronics that you get the image from, and I had to learn how that was actually giving me information and the whole pipeline, because you can't have a black box anywhere, especially when you're doing your dissertation. You need to understand how
yeah.
everything goes from here to here, and you need to explain all of it. like
Yeah.
literally. So I had to actually figure out like the actual code and the actual physical things that were happening inside of this, like, you know pre-made spectrometer that's nice and easy to use. And but like I just figured it all out, and I'm like, oh, there's like a register, and then it clears the register, and then it like, and then based on different, so it spreads the light out into different frequencies, and like that hits the CCD or whatever it is, and based on the location, it's giving you an estimated wavelength, right?
Mm.
Because it splits it up with a basically a what do you call them? Like when you have a crystal and it's like, and you get the rainbow.
Prism?
Uh, yeah, like a prism. It
Yeah.
has like a prism inside of it. It splits it up, and it's real all precise, and and soldered, and like they can't move, and it's. But I had to like
Yeah.
figure all that out, and the whole pipeline, and how my computer was like, how the code was running, and what my like the actual numbers that I'm getting from their software, and like what those literally are, and then
Yeah.
like what my code is literally doing with those numbers, and then how this all makes physical sense.
Yeah.
And yeah.
Yeah. You probably had to understand like tolerances too on every component in that process, right?
Yep.
Because
All adds to the error in the end.
yeah, because I was gonna
Yep.
say, I didn't do a whole lot back in my first college days, but I do remember having to calculate error, and
Yeah.
yeah, luckily we were just doing stupid shit like like we'd have a beaker that only measured in 1 milliliter, you know,
Yeah.
seconds, so it was pretty clear how precise you could be, But
Yeah.
now, if I was dealing with something that, especially like floating point arithmetic on binary systems, I remember the first time I opened up a debug program, and it was like, all right, this value is set to 2.0. It was like zero
Mhm.
zero 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 0 8 7, and I was like, what the fuck is that? What do you mean 8-7? And it was like,
Yeah.
and they're like, ah, don't worry about that. It's just binary truncation. I was like, I mean, don't worry about that. If I say, is this number equal to this number, and
Yeah.
they're off by, the 16th decimal point, and they're just cool with that. And I was like, yeah, but they're not actually off. And you're like, all right, well, someone's going to have to be very clear about that. Like, you know,
Yeah.
I don't know. I don't know enough about it to actually have a complaint. It just, I remember that throwing me for a loop. I was like, well, all this, the more I learn about any kind of trade or science or anything, the more it just
Mhm.
kind of feels like everything's just held together with duct tape and string. You know what I mean?
Yeah.
Like it all just
Mhm.
fall apart at any moment. Everyone's just cool with, you know, I don't know.
Yeah, nobody knows anything. That's the thing. It's that we all have we all have to start somewhere. You have to start from some point, and when you start from some point, you're not covering everything because you picked a spot. And
Yeah,
so
yeah,
when you have like a philosophical theory or a mathematical um, proof or a scientific theory, you have to start somewhere, and we give them different names. You get postulates maybe, and if it's a physics theory, we call it a postulate. But it's what it is you're assuming something is true, and you're not going to show why.
yeah,
Yeah. In math, you call them axioms, right?
yeah,
So you're starting from someplace. I'm not going to prove to you that this is. Let's see, what's an axiom of like arithmetic or like regular set theory? You have to start with something just being something, right? Like a number is a number, and I'm not going to prove why that's the case, you know?
yeah.
Or what is it? I'm not a mathematician, but you start from like saying a number is
I can't remember. It's been like 10 years, but yeah, it was something like given the set of all real numbers, can this is true
right,
for that, and then you work off a proof of
right.
that, right?
And
Something
then
like
I think I think what is it? Gödel's incompleteness theorem. I think more or less what it shows is that there's always things you're not going to be able to prove mathematically when you're talking about. So when you structure, I think with the typical rules of how you do math, he proves that you're not going to be able to prove everything, right? There's
that.
always going to be things that you can't prove because you either have to integrate more assumptions or you uh, aren't proving everything, right?
Yeah,
And that's more or less how I took it. And some people have always taken that to mean that you're never going to prove anything or everything. And then like I watched a video, this guy got really upset because people use Gödel's incompleteness theorem like in everything, and he's like, it doesn't apply to this, it doesn't apply to that, it's only talking about mathematical proofs. And he's right, but the thing is that everyone else is doing the same thing, though. It's not different in philosophy when you start with an assumption and then you build up a framework from those assumptions, because you're not proving your assumption. So your theory, and if it does prove its own assumption, you have a circular theory and it's circular reasoning, and it won't work. It's logically inconsistent. So
right.
you can't do that. You have to start somewhere. And the idea, I think, in general, or at least from my perspective, is that we get more and more explaining power from doing that. And so when I come up with a theory that has different assumptions, the goal is to have it explain more things, right?
Yeah,
Preferably, it explains your assumptions. So let's say you're Newton, right? And I'm Einstein. The
thank you very much.
goal is I can still explain your assumptions, right? And I can still explain why your theory works,
Right.
right? Which is what they did, which is what Einstein did. He shows that in the limit, if you take Einstein's theory, you can show in certain limitations you get Newton's theory, right?
Yeah,
And so that's sort of the holy grail. It's like, okay, this theory now has more explaining power, and so this is preferable. It's not that Newton's is useless. Rocket science is still built around Newton's laws, right?
yeah, yeah,
And it works great. Yet it's actually not true. It's not true. It's fundamentally does not describe the reality of the situation. It is a useful framework, and that's the way all physics theories are. They're useful frameworks. They don't describe reality. I think that's a fundamental flaw that people have thought that we were making these scientific theories and we thought they were telling us about reality when they were just giving us better explaining power. Predictive too. It's predictive, but it doesn't tell us what those things fundamentally are. Right? It never described their true nature. And philosophy, you have the same problem. And so you kind of wake up, or at least for me, I woke up one day and I'm like, oh, nobody knows anything. Okay.
Yeah, not really. I mean, yeah, not really. I mean, even even things that were revolutionary, right? I mean, well, what am I trying to say? It feels like you use a framework so that you can get somewhere, right? Because if you always try to start at the, what is the actual fundamental truth and what
Yeah.
is, um, what's really going on here. If you just try to hit that from the get, you're not going to get anywhere. You know what I mean? It's like
Yeah.
you kind of have to work with this broad framework and then start chipping away at it and breaking it down into more specific chunks that you can make more progress in, right?
Hmm.
Because otherwise, I don't know. It's some reason I got this stuck in my head too. The Planck length,
Yeah.
right? So they call it the resolution of the universe, right? The
Hmm.
What exactly is it? It's like the minimum amount of.
Oh man, the Planck length is so interesting. Um, are you asking me or?
Yeah, 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 yeah.
Um, so, well, one really cool way to think of it is that you can. Do you know what action is in physics?
Go ahead.
Okay. It's sort of an almost abstract type of quantity. Uh, Action's probably a pretty good word for it. Do you know what Noether's? I'm probably saying that wrong. I don't know how you actually pronounce it, but Noether's theorem is.
No.
So you can get um, Newton's laws, and you can get the conservation of energy, conservation of momentum, and things like that. You can get all of these things from a simple starting point, from a simple theoretical starting point called Noether's theorem, and you basically get the Lagrangian, which I'm. Do you know what that is?
Yes.
Okay.
That one I do. Yeah.
So the Lagrangian, when you minimize this quantity called action, you get this Lagrangian, and you get all of the conservation stuff, right? And so you get all of Newtonian mechanics, Hamiltonian, you get all of it, Lagrangian, different ways of formulating classical mechanics. You get all of it from this simple, I mean, from this kind of elegant thing, right?
Mm.
And it fundamentally centers around this thing of action, right? uh, it crops up again in every other major branch of physics. So it's also present in quantum mechanics. And the coolest thing is that when you go to quantum mechanics and you look at action, what you see is that the universe is quantized in discrete packets of action. And
Yeah.
so
Okay. Yeah.
Planck's length, there's a million different ways you can look at it. I think it's about perspective. But what I like is thinking of it is that it's saying that we have this quantity of action, which is kind of related to, it's a little bit like energy. I can't remember the actual units right now, but the Planck's length is in units of action, and it looks like the universe is little packets of action. And I was really enjoyed that.
Yeah. It's interesting, right? Because the way they always taught it in school was they would just put up a really small number and be like,
Hmm.
like they wouldn't exactly tell you how to relate it to anything else except that you needed for a couple formulas. And but what I always understood it to be was basically that. Um,
Hmm.
and I do remember the first time I heard about the difference between classical mechanics and quantum mechanics, and that the reason it's called quantum is because it's quantized packets
Hmm.
of energy
Yeah.
and things like that, right? But
Yeah.
that does seem interesting, right? Something to have a discrete value in an otherwise continuous seeming universe, right?
Right.
So, s- so I mean, it begs the question, right? Is that what? Why is it discrete, right? Or
Yeah.
why is it not continuous?
Well, that was
Who's
the big question Einstein and many others have spent a very long time thinking about, like, what does
yeah.
this mean? I mean, well, it's not specifically that. It's the anyways. Finish your thought before I go off and start saying other things.
Oh
I'm
no,
not
I was
sure
just
which
gonna ask
direction you want
what.
to go.
No, I was gonna ask if you had any kind of experience or knowledge about what fields of physics are have pretty substantially answered that question or are currently working on it, or what exactly is the
Well,
consensus?
none. So I don't. You're not going to get an answer as to uh, the real nature of anything. I think is the most important point to really keep in mind. It's that whatever it tells us gives us a sense of its nature, but it doesn't reveal its reality to us. I don't think that the concept of an electron is describing what an electron is, if
Yeah,
that's like a good way to point. And it's a
sure.
and when I describe nature with quantum mechanics, I don't think that I'm describing some deterministic set of what nature is. I think I have a model on what I'm likely to experience. And that's literally the cubists interpretation, not like the art.
Oh, I was confused. Yeah.
But there's a interpretation of quantum mechanics called cubism, and it's based on, it was originally for quantum Bayesianism.
Okay.
Bayesian statistics are
Yeah.
Bayesian mathematics. I don't know what yeah. um
But yeah. Yeah.
so it's a probability statistics kind of mathematics, and they had this Bayesian interpretation of quantum mechanics, that, and the conclusion is that quantum mechanics isn't describing reality, it's describing your beliefs about reality.
Yeah. Hmm.
It's mathematically rigorous. It's not like woo. I mean, it's a real physicist that have been working on it for a long time. Chris Fuchs is the main guy. I don't
Hmm.
know if it's Fuchs or Fucks, to be honest with you. It's Fuch
Yeah.
S, I think. But
Huh.
anyways, so
Fox.
what? So when you look at that, it's telling you something about the nature of reality, but it's not giving you like the why or the hows or it's sort of, well, it can give you a little bit of how maybe, but um. So what do I think? I think, well, nobody really wants to talk about like what the meaning of quantum mechanics is anymore, because there's too many ideas now there's too many people in the pool, and it's just too crowded. So
Hmm.
you have lots of interpretations about like what these things might mean, um, ways to reconcile the parts that don't make sense, and the ways to like figure out how we could combine general and special relativity to uh, quantum mechanics, quantum field theory. I don't, there. It's just a matter of interpretation. I personally think that Einstein never liked, that God doesn't play dice with the universe. That was his, famous quote. And
Yeah.
so he doesn't like the probabilistic nature that you get. And so when you have quantum mechanics, one of the main, I think, struggles that comes up philosophically is that you have this continuous probability nature to the wave function, and then you have specific values, hard discrete values, when you take a measurement.
Yeah.
And there's a disconnect between this continuous and discrete thing, right? And that's sort of the main problem. So you have the Schrodinger equation, and then it collapses to some probability thing. Something happened, right?
Yeah.
And people always had a hard time figuring this out. And so you had like attempts to try to figure out a hidden variable that would explain and create determinism, you know,
Hmm.
that would give you a reason that this is the value you had to see, right? Does that make sense? So it's not
Yeah.
probabilistic in nature; it's deterministic.
Right.
Uh, so you get, interestingly, the theory that I really like, conscious realism. Um, when you map out Donald Hoffman's formula and his colleagues, their formulation of like the mathematics of how agents interact, what you get is, you do get a hidden variable theory that explains the discrete. It explains this whole problem. It's the hidden variable is agentic choice, and so it's based on agent interaction is
Hmm.
why you get the it's there's no wave function. You can treat it as a wave function, but what you get is these discrete values from agent choice, right? And so it's the math is all the same. It doesn't change quantum mechanics or anything like that. uh, you get everything there, but it sort of says Einstein's intuition was correct and there is a hidden variable. It's agentic choice. You know what I mean?
Well, I'm
Agents are
not gonna
able.
lie, because it feels like every time you try to wrap your head around the perspective of quantum mechanics, it always feels incomplete, right? I
Mm-hmm.
mean, that's just it's probably just human nature, because I know that we're not designed to work with probabilities very well, right?
Mm-hmm.
It's just not
Well, quantum
something that's
mechanics probabilities are even more odd because,
yeah.
like, a regular probability, you just add this probability plus this probability, but in quantum mechanics, they have this weird quadratic nature to them, and you have to square them and then add them. It's
It,
funky. Yeah.
yeah, it's no, it's crazy. And what I mean by that, I guess, is it's just that we're just not very well mapped to understand even what a simple probability really means. You know what I mean? Because it's like,
Mm-hmm.
I remember actually this came up in a game design uh, theory that I was reading or something, and they were talking about how you can't just design a completely random system or something. It's like even say an item has like a 30% drop rate, right? Well,
Mm-hmm.
if you do this thing 100 times and it never drops, right? You feel cheated. You feel like it's messed up or something. How could this
Yeah.
possibly be, right? And you're like, well, it's a 30% chance, right? That doesn't mean that
Yeah.
it's going to drop 30 times at 100 rounds.
Yeah.
It's like yeah. It's just we're
It
just
means you're
not good at
likely to
comprehending.
experience that. Yeah.
Yeah, exactly. So
That's exactly the cubist point of view too.
yeah,
It's what you're likely to experience.
and don't call me a cubist.
Yeah.
No, but yeah, no, it's interesting. It's very interesting. And no, and when what kept sticking in my head, and the reason I brought up this whole conversation in the first place is because having something discrete and quantized like that also just feels incomplete, right? Like
Mhm.
surely there's something else that
Yeah.
manifests itself as this, smallest possible value, you know, or whatever. But I don't, then it always just seems like if you wait long enough, you know, in 30 years, you find out that, elementary particles are actually made up of stuff, right? And it's like,
Mhm.
if you just keep pulling at that thread, I feel like you keep getting smaller and smaller. But there is a weird limit when it comes to quantized values, right? But
Yeah.
I'm kind of rambling here. I'll be honest.
No, it's
But
it's actually it's one of the greatest features I think of the theory of quantum mechanics that it points you directly to its limitations. It
yeah,
says, yeah, it says here's the resolution. This theory won't go past here. And that's what you want. You want, I mean, that's what makes it, I mean, Donald Hoffman says that all the time, actually. So it's like um, a good theory allows you to find its limitations easily. And it's not, if you can't, then you have something that's probably too conceptual. Maybe it's not rigorous enough. You can't see where the actual limits are. Um, when you have a really precise theory that says, oh, right there's a stopping point, that's a great theory
hmm.
because it lets you know but it doesn't know everything.
Fair enough. Yeah,
sort of. So it's you start from assuming something and you're admitting you don't know everything, and then you point directly to where you can't figure something out. That's great.
yeah.
But yeah, so it's like, yeah, it's limited. It's not. So I guess the question is like, oh, is the universe pixelated? Right? Is there some sort of voxel that the universe is made out of?
Kind of what it feels like, right? Yeah,
Kind of like begs the question, but I think no, I think it's just a misinterpretation of what the theory was in the first place. It's its own limitations, not reality's limitations.
sure.
And I don't think that, well, so if we accept all that, the best ideas that we have now point outside of uh, physical time and space, anyways. And so I think that uh, here's an idea. So let's just imagine for a second that like you have a giant, massive, concert with 10,000, 100,000 people, right? Like it's a ACDC old school summertime massive, and they throw these massive beach balls out into the crowd.
Yeah.
You ever seen that? And then
Yeah.
like this gigantic thing is just getting pushed around.
Mhm.
I want like the way I like to think of things sometimes is that that ball is sort of like the electron, and what it's doing is a consequence of the 100,000 people doing things I'll never imagine, right? And
Sure.
on some level, it's like simply they're pushing it around,
Yeah.
and then but it's the consequence of their actions, right, that create the movement of that ball when you're watching it, right? And that's what we think an electron is. You know what I mean? We're seeing
Yeah.
this thing, but actually, there's almost infinitely fractally down onwards. There's agents doing things you could never imagine, right? And that's what I think is really happening. And so, from my own personal perspective, no, I can't prove that. I'm fully aware that even if I was right, that it's not right. Like
Yeah.
in 100,000 years, all of these ideas are going to seem so overly simple, and like babies are talking, or not even
Oh
like
yeah.
it's like ants are trying to figure out what the sun is, and
Yeah. Yeah. Yeah.
it's like that's
No.
sort of the limitations we have. But yeah, I like to think that there's just so much more going on than we could ever have dreamed, and that our theories are only going to get better explaining power because it's fun to play the game, you know
Yeah. Yeah.
at the same time, the truth, whatever it is, has to be fully present. So in its entirety, right? Because I
Yeah.
exist, I'm having an experience. I can tell you, I know for certain that if all of this could be a dream, everything can be an illusion. It's not real, whatever. But I'm certain that something is having an experience right now, and I identify as that thing, right?
Yeah. It's very
So
progressive.
there's,
Yeah.
yeah. So there's truth to that. That's maybe the only truth that we can. But there's an entire truth that exists and is present in that. Does that make sense? Like
Yeah.
that's my perspective. I can't prove that either, but like
Yeah.
that's uh that's what I think. So everything is already all completely here right now, all of the truth, but we'll just never. It's just going to be, we're going to reach for that apple that's up in the tree, and we can't, and drink for the, we just can't quite get there. We're never going to quite get there,
Yeah.
but we're going to keep looking at it. That's what I think.
No, and that's, I mean, that has to be true, right? That can't not be
Yeah.
true. I mean, it's a reality and it works, you know? Um, hmm, it's interesting. That's, you know, it's funny. It also reminds me of when I first started learning about quantum field theory. And granted, all these things I pursue for about, I don't know, a month while I'm falling asleep in bed.
Yeah.
I'm like, oh,
Yeah.
wow, that's really interesting. you know, but the idea of on a baseline is that there's just kind of different levels to things and permeating foreverness and realizations of what we can observe are just excitations in a field, that just
Yeah.
manifest themselves as, like basically when something reaches a certain energy level, right, then it manifests as this thing with these properties, right? That
Right.
all makes general sense to me on a conceptual level. Um, but the thing I kept that kept nagging at me was, well, you can't just say there's a field, right? It's like, why? There's something to the field. You know what I mean? It's
Yeah.
like, yeah, it's like, oh, it's an electron field, it's a boson field, blah 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 blah. And it's like, all right,
Yeah.
cool. What is that stuff?
Yeah.
It's like,
Yeah.
I get that it's just a framework again. It's all just perspective and ways of describing these things that are
Yeah.
useful in certain contexts. But still, it's it's nagging, man. It drives me crazy. This is why I walk around with an earbud in most of the time. It's because I don't like being left alone with these questions, man. I'm
These are
not
good
going back to
questions. I
school to
don't
figure
know.
it out.
I love these. I love these questions. These questions are my friends.
Oh, they drive me insane, dude. I end up in the shower for like 45 minutes just
Mm.
because I'm stuck on something, you know? It's like, but
But what is it? Yeah. Um, well, he's just starting. Yeah, yeah. He's just starting somewhere and then saying, "Watch me play this game."
yeah,
We'll start from like, allow me this thing called a field, and then I'll show you this.
yeah,
And look, it works pretty well. What's a
yeah.
field? I don't know.
I don't know.
It's there. So I think it's there. Something's that, I
Yeah.
think, yeah, those are like, I think it gets down to what so even if you dig down into like the things that I currently hold on to, there's still so many, there's far more unanswered than anything you say adds far more questions than you answer, right?
Yeah.
Um, so it's like, I like to think I'm a non-dualist, right? So I don't believe in the idea that there's more than one thing, right?
Oh, I thought you meant fighting.
Oh,
Gotcha.
yeah. No, I want
Yeah.
to be a duelist. I would totally duel somebody, but not no weapons though.
Oh, yeah. No.
Like if we could wrestle, I'll
No.
wrestle.
If that's how they decided the current working theories for the day, are you
Oh,
good?
yeah, I could probably be up at the top if it was the same.
Yeah.
Yeah, I mean, if you only took the pool of existing physicists,
Yeah, right. Correct. Yeah.
I could probably be somewhere near the top there.
Yeah.
Won't be too many that are gonna, yeah.
Fucking nerd,
But
dude. Sorry.
no, you know what non-dualism is, though, right? Monism,
Monism.
or like not, well, not, people mostly say non-dual, but it's sort of like, I don't know why you would describe it like that, but like a
Yeah.
monism, like mono, one
I
thing.
because monism kind of feels like a Jamaican thing that you shouldn't make fun of. You know what I mean? No, but non-dualism, um,
Yeah,
duality. You're talking about duality, right?
yeah. Do you know what duality is,
I did at one point.
or have a sense of it, or
Yeah.
no? Well, these are philosophical things, so you might not have spent any time contemplating them, so they're like not clear to you what that means.
Fire away.
Well, you like Descartes, right?
Yeah.
Yeah, Cartesian coordinates.
I
You
love
feel like
some Cartesian coordinates, man.
yeah, you know how like it's funny how some of these historical figures you feel like almost like you know them. You know what I mean?
Yeah.
Like like there's a kinship to them. Like I feel like I know Descartes a little bit. Like I don't know him at all, but you know what I'm saying. Like I
Yeah. Yeah.
obviously
Yeah.
I can't know
You're
him,
saying
but
you have a
you know.
parasocial relationship with a
Yeah,
mathematician from hundreds of years ago?
and Newton all the time. I think about Newton a lot.
Man.
Um,
Yeah.
Einstein, all them guys. Yeah.
What a guy.
But anyways,
Yeah.
Descartes. So his main thing, besides like Cartesian coordinates, right, and some other stuff that he had done, was I think therefore I am. That was like one of his main quotes,
Hmm.
famous quotes. You've heard that one.
Yeah.
What he really did was he established the separation of, and we've actually mentioned this before, I think, but he's established the separation of the mind and the body, right? And
Hmm.
so you had things of the mind that existed, and he sort of proved in his own framework. This is so funny. I actually want to talk about that at some point. Like all these ancient philosophers thought they figured everything out, and
Yeah.
they were like,
Yeah.
"Oh, look, my theory is perfect because it's so logically." But it's like, but you're assuming this,
Yeah.
and they're
Yeah.
like, "No, it's so true that it's obvious it's true," and that's how a lot of them would rely on it. Like this is so obviously true that it's true, and
Yeah.
it's self evident. That
I'm not
was
gonna lie,
any.
dude. If I was gonna die at 50, I'd probably be trying to plant my flag too.
Well, I'm really glad they did it, but it's just funny to look at them now because it's like they sort of hinge on, and nobody had the humility to like, say like, "Oh, I don't actually know."
Yeah.
But
There's there's no glory in humility, you know.
yeah,
It's like, but anyway.
but he figured out that you can pretty convincingly separate the mind and the body, and so things of the mind, which you can't really prove with the physical world, was the main issue. It's that like it's not apparent in the physical reality what's happening in the mind, and so he wanted to separate things. That's called dualism, but their dualism existed before him. That's just like the easy one to point to. That's more recent.
Mm,
But so the idea is that there are more than one thing um, where there are two kinds of things, perhaps, right? Um, and it's really hard to construct reality from the fundamental level with a theory without either using dualism or monism. And monism is really tricky because you have to kind of introduce a functional dualism to really make it work, um, which just makes it look like there's more than one thing, right? Um, but
Mm.
so yeah, so separation of the mind and the body, that's sort of the main thing. um, Modern science went into and was like, let's just forget about the mind completely and erase it from existence, and we'll say that everything is physical, and that anything that's of the mind is really just an illusion of the physical. And that's sort of, I think it's pretty clear that that's not going to work long term. It doesn't have very good explaining power. It's lacking in a lot of ways.
Hmm.
um, and it sort of lost the point of things in the first place, right? And so it goes so far as to say like the mind is an illusion and you're not actually experiencing anything, which I find so funny. It's like, well, who's experiencing the illusion?
Yeah. What are you trying to prove, dude?
Yeah. So it's like you can't really get you can't go very far when you only look at the physical world, right?
Yeah.
At matter, quantum mechanics showed that there should have been a pretty much of a death toll for the physicalists, is that quantum mechanics really points to that there are major issues with thinking everything is only matter. Um, that doesn't mean that there aren't things that we don't understand that could explain it. And in fact, I think that's true. I just don't think it's physical matter, physical space time. I think it's there's more things that are fundamental. And physical space time is a useful narrative. It's a useful model. It has a lot of explaining power, but that's not actually what's happening. It's just like what it feels like.
It's a pretty
That makes
bold,
Yeah,
bold claim. Yeah.
I think so.
I like it though, man. It's, you know,
Yeah.
because I mean that's how we were all, or at least us, being the more logical ones of the family, right? I know
Hmm.
going through. I remember there was a point in my life where I didn't have a word for it, but I did, you know, act as though everything was a manifestation of physical reality, and it's like anything that I'm
Yeah.
feeling, anything that's happening to me, everything is a, a a reaction of some kind of physical process somewhere, right?
Right.
And even if you're talking about dreams, right? And it's like a
Yeah.
certain amount of chemical reactions, certain amount of neurons firing, that kind of thing. It's like everything can be explained with a physical process, right?
Hmm. Well,
But
it
it can't.
can't, but
So
yeah.
yeah, yeah,
We
yeah,
can do a lot with it. We can do a lot of explaining,
sure, yeah,
but it's yeah, fundamentally limited. Like, where's a memory? Show me where a memory is.
yeah,
When you
yeah,
start messing around people's brains, you can make them not able to access certain memories. Um, but even then, it's like really hard to completely erase something.
they
And
figured out how to do that.
well, what I'm saying is sometimes you can have certain brain damage and suddenly you won't recognize your wife or something like that.
Uh-huh.
Um,
Yeah,
it makes certain types of recall challenging, but it doesn't prove that like the short story is that they can't find like a memory. There's no like memory storage center
yeah,
anywhere that's like, oh, this is where your memories are. And so like you can look at someone's brain image, you can look at the waves, like literal actual electromagnetic waves, which I think is so funny that people just like don't read into that. But like electromagnetic waves that your brain emanates,
yeah,
and
yeah,
that's how we can read it. You can see almost what people are thinking, right? But
mhm,
it's like, well, where's the memory before you just had it?
yeah,
Where are the things in the dream coming from? What's happening? There's like a real lack of explaining power, right, with current theories, and we keep trying to figure out smaller and smaller details, and it's not working. It doesn't work. So we can't explain awareness is really the crux of it, right? And
mhm,
so it's not required. Like for example, I can make a robot, and the robot doesn't need to feel anything for it to be able to do what I designed it to do, right? And
yeah.
so if I was a robot, why would I have to feel anything ever?
you could. I forgot there was a dog in here with me.
Yeah.
Um, yeah. Now, well, I mean, you could say that it could play an important role because a lot of people, they'll point to these LLMs and everything, and or not LLMs like Alpha Zero, right? That they
Mhm.
is not an LLM, but is an artificial intelligence that learned how to play
On
chess
that.
by playing chess, right?
Yeah.
Um, same kind of same kind of genre, but different execution. You could say that to make progress in the field of AI and stuff like that, I wouldn't be surprised if a level of emotional reasoning or empathetic thought was required to make some decisions, right? Because you can't boil everything down to like you can't give a philosophical problem to an AI, right? If you give it to an LLM, it's just gonna give you 8 different answers every time you ask. You know,
Hmm.
it's like
Yeah.
so. I mean, that's the only use case I can think of to
But
you know
how does it work though? How did it start? How does it work though? How did it start?
which thing.
The awareness.
Oh, how does it work? It
Yeah.
doesn't right now. Yeah.
Yeah.
It's-
So you can't. So like
yeah.
it's just you can't generate it. It's sort of like looking for something by using it to look for itself. You know what I mean? That's how I see the problem of like where does how does consciousness work? How does it it's just it that's what you are in my
Yeah.
opinion. So it's like that's how I get around it. But yeah, I think LLMs with I don't think that consciousness works in the same way in that like thoughts and reasoning like I don't know if I have the same perspective about what they fundamentally are to like really say anything one way or the other about that. Um I don't know that so like I think if you opened up my brain you're not going to find any of those things, right? Um you'll see I think what my brain is a consequence of those things, not the other way around. You know what I mean? Not that those are a consequence of my brain because
Mm,
I have a different ontological uh, starting point. I start from that. I start by saying experience is fundamental, right? So the
mm,
awareness of experience is fundamental. And so it's like, to me, the brain itself is um, what you experience if you would look at it, right? So if you open my head and you saw my brain, like that's your experience of a consequence of those experiences, if that makes sense. But it's like how they impress on you in your own experience. And
sure.
so it's like, it's your own interpretation, let's just say, right? Of
Mm,
what, you know, how you relate with that type of experience. So it's like a thought. I don't think the brain generates thoughts. I guess I should just say that. I think the brain is I don't think the brain is even real in that sense, in the sense that it's like the thing doing anything. I think that's what it looks like to us, if that makes more sense. So
kind of.
those thoughts and the way that they exist in this reality and how they come through this reality seem to be housed in this thing when I look at it. If that makes sense.
I see what you're saying. Yeah.
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 But there's no like generative thing. Like the brain isn't the thing itself. It's like a perception of your experience of that, which is a slightly different nuance and it's functionally not any different. It's not
Mm,
like this changes what anything is, you know? It's like obviously it's still really important and it matters and it exists, right?
right.
um, to be taken seriously. Um, but that's the nature. I sort of think that this is sort of it's like a game in a sense that this is what consciousness does is it plays games like this, you know, creates it, the universe is a playground for it to do its thing. And so it's not that like there's no evolution or there's no change or there's you know like, obviously that's what I see when I look around, right?
Mm,
um and so all of it exists in that context. But yeah, I think LLMs, so it's like are LLMs conscious? So sorry, that's where my head was going with it, right? Like when you were talking about it.
Hmm.
I think that they're an expression of consciousness in the same way that everything else is, and I don't think you can't not be that. In the same way this desk is, this computer, this thing, everything, the air I'm breathing, it's an expression of conscious experience. You know what I mean?
Sure. Hmm. But that's fundamental to everything in the universe, right?
Yeah.
Yeah.
That it can't not be that. It's like, yeah, it just can't not be that. It has to be that. In the same way that everything has to be a part of the universe, because it can't not be. It just has
Right.
to be, right? In the
Yeah.
same way, everything has to be a consequence of consciousness itself, in my opinion. You know?
It's interesting. You
Yeah.
know what I am curious about? Because I know they were doing some work on. I, I didn't know this, but it was only recently that they finally were able to map out an entire like fruit fly's brain. Like that was the
Yeah.
the biggest accomplishment in like neuroscience that they've been able to achieve,
Yeah.
and it was like a year ago or something.
Wow.
I had no idea that we were that far away from being able to even piece together certain areas of neuroscience. You know what I mean?
Right.
Like, I don't know. I just figured it's 2025. I thought we'd be further along by now. And they're
Have it
talking
all
about,
figured out.
yeah, I mean, not figured out, but at least had the data, you know?
Yeah.
Um, but I know that they were talking about getting supercomputers online to map out the human brain. I don't think they're anywhere close to that yet. They were talking like they were, but I doubt it, right? I'm
Yeah.
sure it was just marketing. But I don't know. I'm curious what more data might change this conversation. Maybe not this conversation, but
Hmm.
the conversation about how the brain is actually involved in all those processes
Yeah.
and all that.
I mean, it's gonna. I think it's a tremendous thing, and they should definitely. It'll be exciting. I'm sure we'll learn a lot of things that we don't understand now, but it won't. The problem is that it's not going to change the fundamental issues because we can already look at extremely fine details of neurons and everything involved in them and the atoms of which they are made.
Yeah.
And there's no way for anyone so far. There's plenty of ideas about how it could work, um, and people who spend careers working on it. Um, but there's zero explaining power in any of those theories. Like they don't, well, proving, I should say. So all of those theories are baseless and unfounded. You know what I mean? Um,
Yeah. They're good
and
ideas.
they're not rooted in anything that's observable by anyone, right? And
Sure.
so they're like, hey, we don't like the idea of consciousness not being matter, so here's a framework in which it can be. And then they go on and they can do all kinds of things and explain certain things, but then you say like, well, show me how awareness actually, like, literally show me an actual experience and show me how that is directly mapped to real experiences, like just one, anything at all, any
Yeah.
experience of any kind, just one simple, like, use your framework and show me the experience. And they can't do it. It's just
Right.
impossible. It's not possible.
Yeah.
Could more information change that? We already know about like quantum effects of the smallest things in a neuron and how like they happen. So I'm
I
not
gue-
sure.
I guess the only data that they would get, well, I don't know, but I would assume the only data that they can actually get from it is large scale connections of, you know, of parts of the brain at
Yeah,
small
correlations.
levels, right? But
Yeah,
that's about it, right?
yeah. Hmm.
Yeah. I don't
Well,
know.
no, I mean, like we can look at neurons in a microscope and just see and like we can make petri dishes of human brains and like and they'll do things and they act and we can see all the little things and they can do all the science that we like electron tomography. Like there's all kinds of stuff that you can do and we can draw conclusions about what is and what isn't and how it behaves and all. There's all kinds of, it's just like there's a full science to it, right? It's amazing actually. There's like all kinds of stuff that we do know.
Hmm.
And even with all of that and with all of the little details, we can get human brain cells and then teach it to program computer chips on a
Oh yeah,
dish. Yeah.
I've seen that. Yeah,
So
it's pretty fucked up. dude.
Yeah, it's crazy to think, what is that brain feeling right now? It's probably having a good time. It's probably okay with it. It's like
Yeah,
all I do is I move that over there and it's good.
yeah, and I'm playing Doom all day. Yeah,
Yeah.
you can run Doom
It's
on it, man.
yeah, it's that's insane. So it's like, you know, we have a lot of information already,
Yeah,
and people have been trying for a very long time. It's a pretty big deal to some people, and no one has anything of to show at all. Zero, like zero. There's just nothing. There is literally no explaining
yeah,
of any of it. There's no proof of any of it, I should say. Like they can't actually get something off the ground. Now they have. I'm not saying they don't have frameworks and they don't have theories. They do. They have plenty of them, but none of them actually explain a single thing. Not even like a simple thing. You know.
yeah,
And if you can't do that, you can't get anywhere, right?
yeah,
You're just not going to get anywhere. And so the problem, I think, is that um, it's the wrong question. Number one, how does consciousness get made in the brain? It's not the right question. A better question is like, what is reality? You know what I mean? And how can we answer that? I mean, we've been trying for a long time to do that, and we get better and better answers though, or we seemingly get closer to something, right?
yeah,
And I think that the crux of it now is that we have theories that have better explaining power, that start from a different point, and that point is just honestly, just simply to say that we're just going to treat consciousness as fundamental, and matter is a consequence of, or what we experience as matter is a consequence of conscious interaction, and it's not the other way around. And that just kind of gets you past the hard problem number one, which this is what we're talking about, the hard problem of consciousness,
yeah,
so well, we don't have the hard problem now, we're starting. So it's like it's the same issue you had earlier with Feynman's quantum field theory. It's like, well, what's a field? So
yeah.
I can start from consciousness, and then you'd be like, well, where, where'd that come from? And I go, I'm not gonna, that's not what we're talking about.
Well, everybody just chill out. All right, we just
Yeah,
took one step
yeah,
lower.
yeah,
That's all we're doing.
yeah.
Yeah,
We're saying we're gonna start here. I don't know. I don't know what it is or how it works necessarily,
yeah,
but I'm gonna say a few things about it, and then I'm gonna play a game. And then, so when you start there, we can get physics theories back now, or we're like extremely close. So we already have uh, the the wave equation for a free particle in quantum mechanics. He has special relativity recovered. They're working on general relativity right now, and I think that the rest of quantum mechanics is very close. Like once we get to like the Born rule or something, we're basically done. And then if you get that, then we already are connected, and they already connected to other more fringe, not fringe, but at the edge, the bleeding edge of modern theoretical physics, which is like scattering amplitudes, which we sort of bypass. We get rid of quantum field theory entirely, and we're still able to make predictions, right?
hmm,
Which is and it and it starts outside of space time, so it's literally based on these manifolds of different sorts that you can calculate certain volumes and certain aspects of the geometries inside of these manifolds, and you get scattering amplitudes, direct scattering amplitudes, and it's sort of this weird mystery, right? And they're like, well, this is really mysterious, this thing that doesn't have unitarity. It's not it's We have gotten rid of space and time, and then we somehow get these real answers, and it's done by literally the brightest minds and theoretical physics of the modern day, right? And so it's like, and that's like where they're all going, and they're like, this is it, this is where we're going, we're gonna go here because this is working, and they don't know, and they don't want to talk about it on podcasts
yeah, yeah,
about like why it's outside of space-time, but that's what they're doing, right?
hmm,
So and we have a consciousness first theory that can get you the same math, right? And so you can get from conscious interaction, you can get scattering amplitudes, and it makes conceptual sense. It's not like it's nonsense. It's like it makes the form of how everything works together makes sense. So it's like uh and actually some really interesting takeaways that were unexpected, like it explains why you would have the speed of light in a vacuum, instead of assuming it, which is what Einstein had to do, right? Einstein had to assume these things.
yeah.
we get that as a consequence, right? And so it actually recovers Einstein's theories again. And so it's like, oh, okay, this is amazing. Has explanatory power, better explanatory power. It's explaining previous assumptions,
Mhm.
um, but you're starting from somewhere else, right?
Oh, yeah.
And so it gets rid of the hard problem of consciousness, number one, which is fantastic, and then it recovers our best physics theories, or it's recovering our best physics theories. And this is also perfect because if it can't do that, then perfect. Theory's not good.
Yeah, you
It's
could
not
rule
going
it
to give
out.
us,
Yeah,
yeah, you can
yeah,
rule it out. And so it's like a magical little thing that's happening right now. It's like amazing. And so the more they look into it, the more they get out of it, right? And it's like it's lining up better and better. It's not going the other way. And so, which is really great. And so that's one reason that allows me to intellectually, with my thoughts, right, accept it. But on another level, it's like that never made sense anyways, to think that, like, where do you go when you dream? You know what I mean?
yeah,
Like, what's happening there? um what have all these people been saying when they die and come back? Like, is all of it is just a shared fantasy?
yeah,
Every single one? I mean, it's just insane. There's thousands and thousands and thousands of them, right? And
yeah,
it's like there's more going on. Also, there just there seems to be more, right? And it's like, okay, so I think we're at this point where humanity can kind of take spirituality and science and they come together, right, in this really nice clean way. When you start with consciousness, open the door to 10,000 years, thousands of years, 10,000 years or whatever of human spiritual practices that all sort of line up and say this very similar thing, right?
yeah,
um,
yeah.
and so it's like, oh, it's like perfect little unity thing going on.
It's interesting though, because if it does work out, I imagine there's going to be several years of confusion and friction, and if it gets to a point
Yeah,
to where they can, definitively say like, this is a good theory, this is a better theory, this is what we
yeah.
should be teaching, this is what people need to know about, so we can, you know, continue our pursuits. I just get the feeling that it's going to be rough,
It's
and
gonna be a hard pill to swallow.
yeah, yeah, a little bit.
Yeah. It's because the institutions have become dogmatized.
Yeah,
Yeah.
yeah, yeah. Well, I mean, I don't know. Part of me can't really blame them, right? With how
Oh no.
much strife has been associated with, you know, getting to this point, right?
Yeah.
With a previously, highly spiritual, highly religious culture and
Mhm.
society and everything. It's like, you know, d- hopefully we're getting to a point to where these kind of jumps back and forth are less and less dramatic, I guess, right?
Yeah.
Because it was all spiritual, then it was all science.
Mhm.
Now we're getting to a little bit, a little bit,
Yeah.
just kind of easing in. But
I think they're just going to be the same thing. I don't think there's going to be any separation. And if you look closely, you can see this sort of pattern that crops up a lot. And so science originally, um, had been deeply spiritual. And
Mhm.
so, like science, modern science, you could say maybe has its like most clear roots in like alchemy, for example,
Sure,
which is
yeah,
deeply spiritual.
yeah,
And I think that we're going to see like a return to something more like that. And but it's not required. And I don't think you definitely want to stay away from any sort of, in my opinion, the most dangerous thing you can do is think you're right.
yeah.
And you start thinking that everybody should listen to you. You know, because it just destroys everything. And it's
Hear
like
that,
more of an
Descartes?
yeah, yeah. Well, yeah, just everybody really. And they like, oh no, wait, I've got it. And then like every generation's like, no, wait, I've got it. Oh no, wait, I've got it. And it's like, come on, all right.
Yeah,
It's like, I think that what we can do now is instead say, let's explore. Or that's what I would like to do personally, me personally. It's be like, instead of pretending like any of this is correct on some fundamental level, even my idea of consciousness being fundamental, right? Instead of saying this is absolutely true, it's like, hey, let's play some games and see what's out there. You know what I
yeah,
mean? Let's explore. And you look into yourself. I personally think that that's the direction we should go in. Or that's the direction I want to go in. I don't even know what other people should do, to be honest. If I'm being honest, like I don't know. I can't fucking tell other people what to do
Yeah.
with or even want to. You know what I mean? I would,
Yeah.
but if they ask me, I'm gonna be like, hey, like let's just play around, and see what happens, and see what's true, see what isn't true, or what is truth, and we can just kind of play around with it all and see what comes out, and
Yeah.
that's way more interesting. And some things are pretty consistent, and that's great, but it's still, even those change, right? And it's like it's an exploration, right?
Yeah.
I think that's what we have to really latch onto, and science wants to be that. It just has a hard time getting past spiritual stuff. You know what I mean?
Yeah.
Like it really wants to be. I mean, I think at its core, scientists don't actually have a problem with most of this. I think there's scientism, which is mostly not scientists. Scientists typically, like the feeling that I get when I think of like someone who's actually in pursuit of this, they're really genuinely just out to explore, and they're not going to close the door to something. They're going to Scientists should really be, in my opinion, a mystic. You know what mystics are?
Yeah.
So mysticism is really about experiencing things yourself. That's like what mystic really even meant, was people who just had their own experience, right, of the divine or whatever.
Hmm.
They didn't rely on You don't rely on a text to tell you something, right? You experience it yourself.
Gotcha.
And scientists can be like the crowning achievement of that. You know what I mean? Because that's all they want. They're not interested in what you have to say.
Yeah.
They shouldn't be, right? They're like
Yeah.
more interested in what their experience tells them. Um, Not in a closed-minded way, but in like a very open way, and like, oh, that's interesting. Let me see, right?
Yeah.
And that is mysticism, in my opinion. That's the core idea of being a mystic, right?
Yeah.
A mysticist.
Mr. Mysticist. Nice.
Yeah.
Now, um, no, I agree, man. I think, yeah, the best thing, a scientist should be somebody that lives for someone to ask them a question that they haven't thought of an answer for yet. You know what I mean?
Right.
Or they haven't figured out yet. Right. I
Yeah.
agree with that. I do like the idea of a 6-year-old coming up to you and asking why the moon is in the sky, and you just tell, let's play some games.
Yeah. Yeah.
Like,
Yeah. I mean, that is the best way. I did that with my kids actually this last
yeah,
year.
yeah. I
Yeah.
bet they probably understand it a lot better
Well,
than
here's
most.
what I did. I said, you guys are gonna. I'm gonna try to help guide you to what a physicist really does. And they go, okay. And I go, okay. I said, I drew a picture of a go kart, and I said, if I had a go kart, I want you to tell me how fast it's going. And they go, okay. And then they immediately try to like figure out like mathematically what speed is, and I go, no, 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 you can't look anything up.
Mm, mm.
And they were like, oh, okay. And they're like, well, what's speed? And I was
Like,
like,
I don't want
great
to
question.
go anymore. I don't want to play anymore.
Yeah.
Fucking-
I was like, that's a great question. Why don't you tell me?
mm,
And then they had to they had to do all of it, and they figure all of these things out, and they're experimenting and they're playing around. They ended up coming up with a Newtonian definition of speed. So
Dope.
uh they worked it all out. They had to figure out what averages really were. I didn't tell them anything, and they just spent months exploring, about 3 months exploring these ideas. They ran a bunch of different experiments. I would help them with design. I would mention things, but I just let them do all of it. And then I'm like, okay, well, now you need to tell people about your results. And so they had to learn how to make a website. Because how else are you going to tell people? Um,
Really?
yeah, yeah, they had to make a website. I had it
Dope.
local only because I didn't want them on the internet
Yeah.
unrestricted. So
Yeah.
um, yeah, but they learned how to make web pages, and then they shared their results, and they wrote papers and stuff, and that was like a whole 3 month long experiment that we did. Yeah,
That's dope, dude. That's cool.
yeah.
That's really cool, actually. That's
Well,
man.
that's what physicists do, right?
Yeah.
Now,
No,
is
I
it
fucking
true? I don't
I
know.
hate
I don't
public
know.
school
Was
system.
this?
Holy shit.
I
Yeah.
know it's ridiculous. Yeah,
Yeah.
I mean, no, it's nonsense. So I It is not a place of learning.
No,
Schools
no,
aren't even a place of school. That's not a place of schooling.
yeah, not really. No, it's basically a big
School.
daycare for
Yeah.
kids. You know what I mean? Yeah, for
Do you know what
teenagers.
school means?
Doesn't mean like you told me before. It was like leisure
Yeah.
time,
Yeah.
right?
Yeah.
Yeah,
It means leisure.
leisure. Yeah,
It means we're gonna talk about nothing.
yeah. Well, to be fair, I did do that a lot in school, but
Yeah, that's true. Like what we're doing right now is what the original school was. That's what this would have been thought of as a school.
yeah,
Yeah.
yeah. If I had the luxury to not have to haul 40 pails of water from the well to
Yeah.
my day job, but nah,
To
it's
me,
nah. That's another thing. That's a whole different can of worms that maybe we can talk about some other time. But yeah,
mhm.
that
Oh,
whole
learning. Yeah.
structure needs to figure it out because this ain't it, man.
No,
Yeah,
lost the way.
yeah, like in a major way. It's I wouldn't even say it's good for getting people to the next step because, like you were saying some other day, it's like college is really the first place that I remember actually starting to learn anything. You know what I mean?
Actually, doing the thing of the field
Yeah,
it's labeled like math or science. Yeah.
yeah,
Yeah.
yeah. Like
Yeah.
you can't just put a bunch of well, I was gonna say equations. I actually like math pretty well, but even all the other
Oh, I do
subjects,
too.
yeah, yeah. And the science classes do a better job, I feel like, just because at least baked into it is some, you know, hands-on. You have
Hmm.
there's less of an easy time of just kind of coasting through it because you actually have to do stuff, right?
Yeah.
Theoretically. But man, I don't know. I
It's
feel
definitely
bad.
a lot better than some other things. Yeah.
Yeah. And
Or more
this isn't
useful. Better is not. Yeah.
definitely not a slight on like any teachers or professors or anything like that because I mean they're also just kind of doing whatever the hell they have to most of the time, right?
Yeah.
But I'm sure if you polled any teacher, like someone that actually loves to teach and loves to share knowledge of a subject, right? And you just gave them full free reign, no scorecards, no nothing, no standardized tests, no prep exams or anything. And you just said how would you take someone and make them a master at your level or higher in this subject? Like
Right.
how would you spend your time doing that? It
Hmm.
seems like a pretty simple fucking task, right?
Yeah.
Yeah. But I don't know. This
Yeah.
whole
They're.
results driven everything is just it's nonsense. Yeah.
I agree. Yeah, I could spend a lot of time talking about that. I won't get into it now because it'll just crack open and I'll keep going.
I know. Also, it's kind of bumming me out a little bit.
Yeah.
But
No, it's there's so much, but the good news is you don't need any of that, and you can do it all on your own. Exploring is the main thing, and what do you want to explore is up to you. Uh, there isn't there's very few things that you're going to do that are they're going to be like not useful.
yeah,
That's the problem, is that learning will always happen, and unfortunately it's how like the education system can justify its existence still. And I'm a part of academia, so I'm not saying that you shouldn't be a part of it or something. It's just that I wish that it actually did what it was striving to do. you know
yeah,
um when I mean, we can verifiably show that there are better ways to do all of it. um yeah, you're leaving a lot of money on the table, I guess, is what I'm saying. So like, you go to college to get a college degree because you expect some proficiency, but really what it is now, it's more of just you need a college degree to say you have one. And it's a credentialing experience versus like a learning experience. I'm not saying you don't learn, obviously you will,
yeah,
but yeah, there's better ways to do all of it. There's so much. It's like when you can watch it happen if you watch small children playing, and all they want to do is like, what's over there and what's under the rock, and let's build this and let's do that, and that's all they want. That's all they want in their whole life, is to play around and have fun.
yeah,
And then you put them in school, and then just watch over the next 5 or 6 years as their soul gets sucked away, and they hate sitting in that room and being told what to do and learn this, learn that, when there's other ways to let them find these things and have them actually enjoy it. And why do they need to learn it in the first place? That drives me nuts. I know I'm not saying people shouldn't be able to read, but what exactly are we compelled to force people to do it for? Is it the
Yeah.
case that they're not going to want to read? Who in their right mind is going to be 20 years old and not want to learn how to read? You know
Also,
what I mean? I'm
it
not
feels
saying
like
every person, but you know,
right. Well, also, I don't know, man. It's 2025, right? In America,
yeah,
I feel like it would be hard to be an adult in America that doesn't know how to read, right?
yeah. I don't know
Like
if you can do it really. You
I
have to at least to
yeah,
some like third grade level or something. You know?
right. And it's like, yeah, I mean, I knew a lot of immigrants and stuff that, came over and stuff, and they were pretty fresh. But even
Yeah,
then, you spend long enough in a place, you pick it up pretty fucking quick, even if you're
right.
60 years old, right? It's
Read a
like,
menu, kind of thing.
yeah, yeah,
And if you can make it to 60 without reading, did you need it? You know what I mean? Like if
yeah,
it wasn't necessary until now, I don't know.
yeah,
But it's like, why force people to do things that they don't want to do, especially like a 5-year-old, and then ruin it for their whole life, you know?
yeah,
Because then kids don't like to read and they don't want to do math, and they think math is adding numbers together, and it's like, oh, there's just so much more to it, and it's so much more fun to
hmm
play around with ideas. And at math is like the rigorous exploration of imagination,
hmm
and they literally turn it into a list of things to do. It's like, how could you be more fucking boring? You know what I mean?
yeah,
Like, it's like the imaginative exploration of thought itself in a precise way. And you strip it down to like a bunch of fraction rules I have to remember for a test. It's like
yeah,
someone should just like slap them. It's like making art about uh rules. And it's like, that wasn't that's I mean, yeah, rules exist in art, but they're more like creative constraints on the form itself, not like a thing that needs to be its own thing.
yeah. Well, and that's why you end up with a lot of people these days when they try to pick up some kind of creative, endeavor, and they are just kind of locked into, they can't make an artistic decision to save their fucking life because they don't know if it's right or not. You know what I mean? It's
Right.
like they can't function without
Yeah.
validation that the thing
What am
that
I
they're
supposed
doing
to
is
do?
acceptable. Yeah.
Yeah.
It's like,
It,
and
that
I
was
I
never
think
the
that's
point.
100% a condition of general
School.
schooling.
Yeah.
Yeah.
That's literally what they tell you. There is a right answer. Oh,
Yeah.
you got this answer wrong. You're incorrect. And so
Yeah.
you acquire this thinking that, oh, there are right and wrong ways to be in everything. And they teach you that, and you get a grade in art class. You know what I mean? And
Yeah,
it's
isn't
like,
that something, huh?
yeah, it's so absolutely insane to me to imagine doing, like, if you took any, like you had said earlier, like you took any expert, like you took a real artist, and they say, okay, I want you, there are these children and they really love to do what you do, and we just want you to help guide them so they can explore this. And it's like, no one's going to be like, let's give them grades, let's give them assessments, let's make sure that they're, you know what I mean? Like, what the fuck
Yeah.
are you talking about?
Yeah.
Like, just they're all the artists are gonna be like, oh, let's go have some fun. They're gonna play around. And you're like, oh, like, what do you can do? Oh, wow, it's gonna be like
Yeah.
that, right?
Yeah.
But yeah,
No,
but we should tackle that maybe next time.
yeah.
Education is a big one for me. I spent a year in a education program, so
Yeah. And you raise your kids.
yeah, oh yeah, I homeschool my kids forever.
Yeah.
So doing it currently as we speak, actually. So,
Yeah.
all right, what do you say we stop that here?